Well, hello friends. Today we are going to do some kernel work. So let me tell you about mmap. Now, when you call mmap in Serenity, what we end up doing is, depending on whether you're, so we end up here, by the way, in the sysmmap implementation in the process class. And depending on if you want an anonymous mapping or not, you get either a anonymous region of memory, or you get a file-backed region of memory, which is this code path here. This is kind of messy, actually. Hard to follow. But anyway, and what we do is we allocate this thing called a region. And region is a per process object that represents a memory region. And I can show you what they look like in the process manager, actually, if you bring up the system, just to make it a little bit easier. So we can look at the terminal app here. If you open the memory map, then everything that we see here, every line in this table is one region. So this here is just like a little helper region that we use to load the entire binary of the program. And then here is the actual elf program specified, like specified by the linked together binary, where we should put the elf in memory. So all the program code is usually in here, and this is the data segment, and then here's the stack, and so on, like memory allocations and memmaps, and whatever. Anyways, each one of these is a region, right? And some of them are anonymous, like these guys here are anonymous. Anonymous means that it's not backed by a file on disk, but rather it's just floating in RAM. And then here, these guys here, these are not anonymous, these are file-backed, so these are memory-mapped fonts. And the way that this works is that, excuse me, is that every one of these regions has an underlying thing called a VM object. And the VM object is global, so it's shared between all processes, which is what allows you to do things like shared memory and also efficient sharing of memory mapped files. So the VM object can either be anonymous or file-backed. You can see these here. And if it's file-backed, then it has an inode internally and an offset into that inode. Although maybe that offset should always be 0, I'm not sure. But anyway, and then we also have, if it's an anonymous, then it has the inode, but it doesn't use the inode. And then, yeah, so every one of these regions here has a VM object underlying it or backing it. And then these guys here, these memory map fonts, these are very, very likely also shared by regions in other processes, but it's the same VM object. You with me? Okay. So what I'm going to do today is to take this VM object class and then make it a little bit virtual so that we can have two variants of it, one anonymous VM object and one inode VM object. And then I can get rid of this situation here where all VM objects have inodes because that's not the truth, right? And then we can clean up the interface a bit, because then anonymous VM objects don't need to have like inode getters, inode offsets, and these callbacks for when the inode metadata changes, things like that. And also, this will make the class a bit smaller for anonymous inodes, because we can get rid of 2 members, but we will have to pay a new member. We'll have to pay for the virtual pointer, or the vtable pointer. But there will be a net saving for anonymous ones, which are the vast majority of VM objects. So it's a little bit of a memory gain, but this is mostly about cleaning up the interface and improving the abstraction. So that's what we're going to do today. So thank you for listening to that long intro. Let's get cracking. So let's see. First thing is that we are going to add, I guess we'll add it here. We'll call it anonymous VM object.h and inode VM object. That's pretty good. We'll start with those. And then we'll say that this class is now has a virtual destructor. And by the way, we can QCreator has this lovely feature that if we hover over a class name, it tells you how big an instance of this class is. So we can see here that if we add a virtual destructor, then it goes from 48 to 52 bytes. Look at that. Oh, actually, we already had a destructor. But anyway, so now we've increased the size by 4 bytes because we're on 32-bit. Serenity is a 32-bit operating system for now. That will change in the future, but that's not something I'm working on right now. People keep asking me about it, but there's just so much other stuff to do that implementing 64-bit support is not like, there's nothing that's like blocked on 64-bit support really, so there's a million other things to do first that just seem like more value. So let's see. All right, so we need that to be like that, and then I guess we can start to sketch out this thing here, because it'll be quite kind of easy because we're just going to move stuff over. So inode VM object is going to be a final, because we're not going to, nobody's going to subclass this guy. So VM object, and we'll set like that. And then I guess we'll put a helper to instantiate one of these. So VM object, inode VM object create. So corresponding to this one, I guess. So create with inode. And I think we should require passing an inode here. So the previous API was taking a ref footer to inode, and this can be null. And I don't think that's valid. Yeah, look here, we're always dereferencing it right away. So this is a bad API. And whoever made this, me, made a mistake. So we are correcting that mistake in the new API and using a non-null ref footer so that you can't pass null to it. Okay, let's get some includes here. And I think, oh, well, actually, we're not going to need that. So everything we need is almost already pulled in from vmobject.h. I mean, obviously, because we were able to implement this class. Okay, so then we have that, and then let's move over these guys. And we can actually change these to references because we know that there's always going to be an inode now, so this is kind of comfortable. It's going to be very comfortable, actually. I love this type of thing because it's so nice to type inode dot, you know, rather than inode arrow. So very nice. Okay, so non-null ref footer to inode and inode. And we also need this guy right here. It's an off t. Why is it an off t? Off t is assigned type. We don't need that. I think we can just use a size t. So let's move that out, and let's see, what else do we need? I guess these two. Just put them here. And now is anonymous is going to have to work a little bit differently, so it will be a virtual bool is anonymous. I guess we can do it this way, return false. Designer, return false. And then they can just return true in their corresponding overrides. Override. Notice that I put this override here in the private section. It's a nice little trick, I think, to prevent you from calling is inode, to prevent you from calling is inode on a pointer that is already an inode VM object. Because if you have the right pointer type, if the pointer type tells you that this is an inode VM object, then you don't need to be calling as inode. So putting these under private, nice little trick. Okay, so and then I guess we can also take this constructor, put it here, make it explicit. I always make single argument constructors explicit, except in some rare circumstances, because this prevents accidental type conversion when passing things around, and it's super irritating when you get like an implicit type conversion because you forgot to make some constructor explicit somewhere. It can lead to some really confusing situations. Okay. Okay, I'm stupid. I have to type inode there. I couldn't figure out what was wrong with it. All right, and then we get rid of that. And I think we have the meat of the class here, or at least the definition of it. So then let's do anonymous VM object. Oh, wait, not up here. Down here, please. Class anonymous VM object. Final. Public VM object. Ooh, this is, yeah, I like this so much already. That I hadn't realized before that inode was going to become a reference getter, and that just made me love this so much. I'm just so happy that I'm doing this now. So let's see. Let's make a creation function. I guess we should have both of these. So this here is a kind of a special thing that we use for things like when you're memory mapping some hardware, some like memory mappable hardware stuff. And I think that's going to have to go into anonymous VM object for now because at least it's not file backed. But maybe there should be a third type for these. I'm not sure yet. We'll discover that later on. We want kernel VM, VM object, but since it doesn't have an inode backing it, so this could be something like the video card's display pixel buffer or something like that. We'll come in and create one of these guys. Okay, so then let's do that virtual bool is anonymous. Return true. Cool. And we get the constructors here. Okay. Anonymous. We don't have size T. This is so strange. Why don't we have size T? Okay. Oh. Well, that got weird. Anyways. Wait, what the hell is this function for each region? How does that work? I don't know how this works. I'm just curious. I'm just going to look it up. For each region. Iterates over all the regions and checks the VM object pointer. Ugh. Oh, I see. So here's a little fix me about that. Okay, well, never mind. So apparently there's a very inefficient way to iterate over all of the regions that refer to a VM object. But we don't care about that right now. And then the clone function is going to need some help from the subtypes. So I guess we'll say static non-null ref per, or this shouldn't be static actually. Anonymous VM object clone. And we will have the same thing in the inode version. So guy's gonna need to be able to clone himself too. Okay. So maybe we're cool with that. Let's see. Let's try to implement one of these. We're gonna need some CPP files for this. Okay. It's just to get ourselves to a sane place here. All right. So let's go look at inode VM object. Kernel VM inode VM object. And what functionality do we need? And what can we steal from VM object? I guess a whole bunch of these. So this is the, what will now become inode VM object. Create with inode. Non-null ref footer node. I wonder why why are we requiring a R value reference here? This seems kind of weird. Create file backed. Yeah, I don't know why we were requiring an R value reference at all. Like we could also just do this, because we don't need you to give up ownership of the thing you're passing us. So we should just do this. This is something that like I often screw up on, or like I don't think clearly about. Like passing a non-null ref footer like this, what you're communicating with this API is that the caller has to like give up his non-null ref footer and move it to us, right? Move it to the callee, to the API, and you can do that for efficiency's sake, right? Like if you take something like, you know that the calling client is not going to use this object anymore, so taking an R value reference here allows you to move that object to the API and maybe avoid making a copy. But I think that it's very ambiguous what you really mean by this, and we can disambiguate, or whatever the word is, by doing this, because now we're just telling the API user that that you need to pass as an inode and it can't be null, and that's it. And then what we do with that inode internally, that's, you know, it's none of your business. What we are going to do, of course, is take part ownership in it. So let's see, return type out of blah 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 is blah blah blah, because it's the wrong return type. And then we'll do this, this, and this. So yeah, so here's how the sharing of inode VM objects works. Is that if you try to create an inode VM object, we ask the inode, hey, do you have a VM object already registered to you? If so, we just return that instead. And the getter here is called VMO, because I used to call these VMOs instead of VM objects, but I'm kind of starting to like calling them VM objects better. VMO, just, I thought it was this type of thing that would get catchy, but it's not really. So VM object sounds nicer. Anyways, we'll let's run the trivia there. File system inode. Okay, let me open the window a little bit actually. Get some oxygen here. Okay. Look at those nice dots. Aren't they nice? I think they're nice. Okay. So that's that function, and then we will also take this one, the constructor here, and this will just be inode VM object, and we're going to make it like that, and here as well. Don't need to move here, makes it a little simpler. And you must explicitly initialize the base class. All right, hold on. Do we need to tell the base class anything? I guess not. We just need to have a constructor that we can call. So we'll have one, don't worry. Now we don't need to call that anymore, I think. We can just do this, this, and this, and we don't have to assert because it's a reference. Okay, and right, so this is the part about stuff that's now in the base class. So let's move this out of line, and we will add an out of line constructor here that does this thing. This is register the VMO, the VM object with the global VM object map, so we can find it. And then we should do this. And I guess we'll pass this up like this maybe. So I know dot size. Maybe even seal div inode size, page size. Is that cool? So it's kind of this constructor that we already had actually. It's doing exactly what we want. So I think size is the one thing that we are going to want to pass from the subclasses, so maybe we'll just have that then. Size t, and then we'll make this explicit once again, and maybe we're in a good place with that. All right. Fine, and then the inode offset can just be 0. Is that actually used anywhere? Inode offset? Does anybody set this? Nobody sets it? Nobody uses it for anything? Maybe we can just get rid of it. I guess that inode offset change is going to kill our memory gain from this, or at least make it disappear, but I think the abstractions are just going to be so much nicer, so we'll keep going. The memory gain was just frosting anyway. So, and here, this goes in the inode VM object destructor, which we also need to implement. So I'll take this, put this here, and we can use that. And the destructor is implicitly declared, you say? Well, let us then explicitly declare sucker. Cool. And I guess we should do this in the here as well. All right. So then clone should be if is anonymous. Diecast anonymous. We have to include these here. Wait, what am I even doing? What am I trying to branch on the type? This is so stupid. I should remove that and make these virtual. What was I even thinking? And then here we'll say, oh, can this fail? Clone. It never failed. Wait, clone never failed. That's cool. Okay. Then let's just simplify by making this virtual, saying it's pure virtual, so you have to implement this. And then we'll say virtual, override. And sadly, we have to use the wider type, but that's okay. Same thing here. Well, it doesn't really matter. That's good. Okay, so then this stuff here, inode size changed, and inode contents changed. Kind of semi-implemented functionality there. Need to get back to working on that at some point. But for now, we are just going to move these into inode VM object. And this guy wants to change the size and all of that jazz. So I think the most straightforward way to deal with that is to just move these members here up to protected. I think that's okay. And then, yeah, I think that's okay. Let's see, for each region, that helper needs to be protected as well. And then we need to get some headers. Do we have any more red? Undeclared identifier MM. Well, I know that one. That's the memory manager. And now there's nothing red left here on the scroll bar, so that's cool. Right, so let's go and do anonymous. Kernel VM anonymous VM object. And then I guess we can start with these. Anonymous. Oh, and we can actually improve these return types a little bit. Cool. And then we'll also take those two constructors and put them here. And we don't need to do this because the base class will do this now. Anonymous. And actually, this one just needs to call up to the base class. So we just do VM object size. That's easy enough. And then this guy, he calls the base class, passing the size. And in this case, we want to set up the physical pages list ourselves, so we don't want the base class to do it. So what the base class will currently do is nothing. Where are you? Here. Oh shit, I actually removed. Oh, that was the implementation I took. Right, so let's add a flag to this guy. We'll call it like, should fill physical pages. No, yes. guess should fill physical pages, or we can just say even. No, should is fine. And then in anon, call it saying should fill physical pages. Yes, but in this case, no, because we do it manually here. Okay, and then I guess we gotta remake that constructor that I got rid of. So that's just m size is size, and then for size ti. Or actually, hold on, just a physical resize. M size. And we have to call this, because we are the base class. And should fill physical pages, should fill physical pages. Okay. Fill is kind of an overloaded term here, I guess, but yeah, it's okay. It's okay. Then we need physical page. Okay, and what do we have left? So now we are down to the copy constructor, which is just all kinds of wrong. So I think we'll just simplify this a little bit. We'll get rid of that and that, but we'll keep the rest. We'll make it into a regular copy constructor, because why not? And then let's also do, while we're here, let's just for safety's sake, let's delete some stuff. So let's also delete move assignment, and also delete move construction, just to be on the safe side. Okay, nobody tries to do those. And of course we've changed all kinds of APIs now, so things are not going to really work yet. And also we didn't implement clone, I think, anywhere, so let's do that. And the destructors are missing too. Okay, so how do we do clone? I guess this is just a matter of creating a new one that calls the copy constructor, so like that? Is that it? Is that all we need? And I guess we should do the same thing here, actually. So anonymous operator. Okay, and let's do the same thing in inode. We need the copy constructors, but we don't want you to assign move, assign copy, or copy construct. Yeah. Right, and then let's see. Oh, right, this one should. Yes. I like using enums for flags like that, by the way, because it makes the call site read that much better. Like, should fill physical pages? Yes. Should fill physical pages? No. Like, I feel like this is so much more understandable than that, right? Because you have some chance of understanding what's going on. Like, okay, so it doesn't fill them, and then it adds them here instead. It's nice. Self-documenting code. A lot of people shit on self-documenting code, but I think that it's something that you can do. You can do pretty well if you are willing to write things out and spell things out and use descriptive enums and names and things. You can achieve a pretty high level of auto documentation, which is something I try to do. Try to. Anyway, so what was I doing? The copy constructor, right. So since Anonymous doesn't have any interesting members of his own, he will just basically just be invoking the parent. And he has a private copy constructor. Well, aren't you fancy? Guess I will make that protected. And we'll do the same in inode VM object. So here, inode VM object. We'll just call the parent. Okay. And this one is deleted. Oh, wait, hold on. Why is that deleted? Non-null ref footer. Oh shit, wait, back up. Oh, yeah, right, because this one does have members. So we have to initialize this guy. Silly. And that, by the way, is what happens if you try to create a non-null ref footer that doesn't have value. It's not going to let you because it can't be null. It's in the name. I know other MI node. There we go. Cool. What's this big F0 block here? Pay no attention to that. Okay. These classes are starting to look good. So I guess we can start to look at where they're used. So let's see. Create anonymous. Do we have many of these? It's not terribly many. Okay. So VM objects. I guess we will just do anonymous here. And where was it? Here. Let's say anonymous VM object. Create with size. We'll call it create with size instead. Create anonymous is super, like it's redundant when that's the class type, right? So we'll just call it create with size. Create. More self-documentation. Because see, this is quite readable, right? Like the VMO is equal anonymous VM object create with size. Like you can really read what's going on here, hopefully. Okay, so then let's find more of those things. Wait, what? That's all of it? Anonymous create with size. Kernel VM anon. And then this guy as well. And this guy needs to call inode VM object create with inode. And oh, this is kind of a mess here because this guy is taking a ref putter. He should be taking a inode amp, I think. So that's something else that we can fix. Let's see who's calling this guy. Maybe we leave that alone for the moment. This assertion goes away because actually the assertion changes. So we assert that it's not anonymous, right? We can assert that it is inode. But we don't have to assert that there is an inode, because if it is an inode VM object, then we know that it will have an inode because it's a reference anyway. Okay, page in from inode, blah, blah, blah. That's cool. And did we have any more of those? No. Okay, so let's see how far we can get. Create file backed. Okay. You will be called inode VM object. Create with inode. Then I have to include something, I bet. Kernel VM inode VM object. Okay, what's wrong with this? Oh, that's an inode star. Well, it should really be non-null at this point because we're in do exec. So description. We actually hadn't checked that before. Well, let's just assert it. We were opening a file, so it should definitely have an inode. Okay. We can speed this up a little bit. Okay, memory manager. Here we're gonna have some red. No member named inode in VM object. It's okay. That's fine. Then auto VM object inode is no inode VM object. And then down here, inode offset. Well, we know now that it's always 0, so we can just reduce the complication there a tiny bit. I don't know what I was thinking, having an VM objects have an offset into an inode. I guess it made sense in my head at the time, but I think that was like before region and VM object were separate things. Because they used to be one thing, but then I realized that this is not going to be very efficient if every process has its own memory mapping of a file, because sharing is caring, and they got to care about each other. So now the region can have an offset, which makes perfect sense, but the VM object shouldn't. Okay, so I think maybe that was the whole change there, and then we have some red down here as well. This is in the page fault handler, so here we should say if it's an inode, then we call page in from inode. Yeah, that's all we need. Because this was effectively just a type check. So we're converting it into a real type check like that. And where are we instantiating this godforsaken template? VM object 40. That's where it is. Declared using a local type. Used but never defined. So, oh shit. Oh, I think I get it. It's used here in inode VM object, but it's only ever defined in VM object CPP. So we just gotta move that here so that we can actually see it. It's not super beautiful, but we can leave it like that for now. BXVGA. So this will be anonymous. Create for physical range. Wouldn't it be nice if this just worked? Inode CPP, right. So that's the callbacks when the contents change. So the inode VMO, we should actually have a stronger type here, I think. So this could be like an inode VM object. That's kind of cool. Why don't you love me? Inode.h. Oh, right. Because we gotta do this. That's pretty cool, though. Actually, have done this in other places. Like here, this one is always anonymous. So do that and do that. I like that type of change. More self-documentation. And then a shared buffer is also always anonymous. So that's really neat. And then we didn't implement inode VM object clone. Fine. Dot new inode VM object. This. And oh, right. Yeah, clone is virtual, so it was using base class as the return type. Oh shit, we're compiled. Let's compile everything. It will be fast. I have Ccache. I love Ccache. And let's run. And it falls apart. Okay. We are making user space stack for the main thread. We try to allocate a region, create user accessible region, create size. And we are out of memory. Oh, I bet that's because I made a stupid dumb mistake. And I can already tell what it is. That we should resize it to the page count. not to the size of the VM object, because the VM object might be like in the gigabytes, right? So we don't need a gigabyte number of entries in the physical pages vector. Calling a base constructor other than the copy constructor. I'm not sure what that means in this context. Okay, so we got up and running. Let's try something. Let's try something else. Can we get some processes going? Plop. Let's look at some tables. Let's see, terminal, memory map. Well, it's pretty cool. It's pretty cool. Nothing here looks out of the ordinary. Okay. Okay. Well, that was pretty straightforward. So this is the new VM object base class. Let's just scan it over to see if there's something that obviously shouldn't be here. So we can get rid of some includes. We don't need batch, we don't need string. Can probably get rid of that. We do have a vector still. Actually, we did have a ref footer in that vector, so let's leave that alone. Oh wow, is that what happens if you... Gross. Let's do that then. I hate that client format doesn't let me do this, because if I auto format, it does that, which looks like ass. So I do that, which looks like this, which is slightly better. Still though, like, you could let me put it on one line, bro. Anyways, we do have a lock, yeah. Do we need the Unix types? I think we don't. And the physical address, we don't need physical address. That was in anonymous. He has a physical address, yeah, so we'll just put that here. Yeah, that's pretty good. It's pretty damn good. Clone. I wonder if we could make this const. I would like this to be const. Can we make it const? Maybe I should just leave that alone for the moment. Worry about that some other time. But basically, I think that this looks like it was very successful. I'm thinking, like, could you, I guess you could determine the size from the count here, from the entry count, but I'm not going to mess with that right now. But it might be a nice little optimization, because right now this vector here is very bloated, actually, for our purposes, because vector has like a size and a capacity and a data pointer, so it's like 12 bytes. If you look here, and probably the vector size and this size is the same. So anyways, that's an entirely different thing for another time. But I think I'm gonna be happy with this. So yeah, let's see what we have here. Good God, big changes. But we've been over the code quite a bit. So let's commit this. Kernel. Split VM object into two classes. Anonymous and inode VM object. Anonymous VM object represents anonymous. No file backing. annotations. I guess we could say this the other way around. VM object is represents a VM object with an underlying inode that provides the underlying inode in the file system. Anonymous VM object has no inode, only physical pages. I mean, yeah, can't think of that much to say about this change. Yes, I'm happy that inode VM object inode can now return inode instead of VM object inode returning inode star. You gotta celebrate the little things. So what did we end up with here? So this guy now is 44 bytes, and anonymous VM object is also 44, and inode VM object is going to be 48, I guess. Yeah. So that's something that can be shrunk further, but this is really quite nice. Inode contents changed. This guy takes an off T. We should probably wait. Should we take an off T here? This doesn't make any sense. Let's take a size T offset, and or you know what? I'm not going to mess with this right now. Let's just leave it alone. But we can include Unix types.h just so we get off T here to make the header look right. So then we'll also include that in the commit. Oops. That's a big commit. Not terribly large increase in code size, 86 more lines. Okay, I think that's okay. So I think I'm pretty happy with this. It's a nice improvement, I think. I don't know how many times I'm gonna say that. Am I trying to convince myself or what? No, I like it. So I guess this is gonna be it for today's video. If you made it this far, then I thank you for hanging out with me on this little refactoring adventure. And for stopping by, for hanging out, for leaving your likes and comments, and for subscribing, and like for the fact that you come here all the time and hang out with me. That's really nice, because this is so much more fun with you guys around. So thank you. And there's a weird emptiness I'm feeling from like not building something visual, but like just changing stuff around. But this is good too. You got to do these too, and it's nice to show that type of work. So thank you for watching, and I will see you next time. Bye.